So this is my basic plan. This is a rough drawing of my house. It's a standard suburban house for this part of the world. It's 2 stories, extension on the back. I have a front garden and a back garden, which aren't that big. You know, the front garden would take our cars, and the back garden isn't enormously big either. So to utilise as much space as I possibly can in my property, I plan to put my mast on the back of the house here, and run the legs of the antenna off that towards the front and then towards the back garden. I want to be able to transmit when I get my license on as many bands as I possibly can. So this is why I've picked what's called a doublet antenna. It's fed with what's called an open wire or twin line. This is it here. It's 300 ohm ribbon. Ribbon wire is another name for it. And really why I'm picking that is that eventually when I get what's called an automatic matching unit or tuning unit, it will give this antenna the ability to transmit on various different bands. One of the major reasons I'm going for this is it's particularly down to 2 guys, and I just want to give them a shout out anyway. And I'll put up links to their websites or their YouTube videos on this video. One is Ray, and his call sign is G4NSJ, and that's Ray from Radio Workshop in the UK. He's a very practical, knowledgeable guy, and he has an excellent video on why the doublet is such a good area or antenna. And the other guy then is in the States. His name is Dave Tadlock, and he's KG 0ZZ, I think is his call sign, but Dave Tadlock. I'll put up his video link there, and he also is a great exponent for the doublet antenna and its overall capabilities. Okay, so welcome to part 2 of my video, my journey through building a doublet antenna. It's my first time to do anything like this, as I said in the previous video. So I've got the components together and have begun the work. So as I said, I'm making the feed point connector, the housing for it, out of wastewater pipe. So I have a drill stand here, and I've already drilled out this element. So these are 8mm holes, and these will take these eye bolts. And as you know from the previous video, one eye bolt is going to be used to suspend the feed point connector for the doublet, and then the 2 other eye bolts either side will be the anchor points for the antenna, the radiating elements for the copper wire. One handy thing about this type of plastic I've just found, because I drilled it, is that it threads itself quite neatly when you screw in the eye bolts. If you're what I find, if you're attempting anything like this, due to the curvature of the plastic, along with regular washers, I've also got some split washers, and that just helps to fix these elements better to that curved surface. So I'm just going to put those elements together now. So as I said, this will be the anchor point. On top. And then inside, which is kind of tricky to get at, just more washers. Okay, one more, and then on the other side I'm using this nut here, which is like a locking nut. It has a little plastic part on it, and that just enables the out to tighten a little bit better. Bit of spinning there. Yeah. Okay, so I found out tightening these eye bolts a little bit tricky. So what I've done is I just put it into my this is my drill stand here, has a vice on it, so I'm just going to put that there to stop it from rotating, and then yeah, basically use a spanner to tighten it up. So it's just a little not that easy to get access in, and there's very little turn on it, but there's enough on it to tighten it. So okay, so I've got this part made up. The next part then is bringing the ladder line up into the feed point connector. So I'm using the same pieces. This basically is this plug element of the waste pipe. Okay, so that's what it looks like normally. So what I've done is I have made a slot for the 300 ohm ribbon, the ladder line, and 2 holes to the side. They are for some wing nuts that are going to hold down a fixing that will keep the ladder line in place, part of the mechanism to keep it in place, to keep it hoisted up. So these were just 2 holes drilled and then just filed out, and as you can see, the ladder line just slots up into it. You know, it's a snug little fit. And then the plan is that if I just turn this over here, there'll be 2 wing nuts. These guys just screw in, okay, and what will happen is that when they're in place, as you can see, there's the spaces, or the open sections. I'm going to use that to my advantage to anchor the thing in position. So what I'll do is I'll use this heavy duty cable tie, and just through a system of washers and so on. What I'll do is lock it down, and this will prevent the thing from pulling out. As you can see there, I can't pull it out with the cable tie in place at all. So I'll rig that up, and I'll show you next what it looks like in action. Okay. Okay, so after a little bit of fiddling around, that's it, just those 2 little bolts with the wing nuts. Now I just found when I was doing this, just the wing nuts were a little bit close to the edge here, so there wasn't a lot of clearance. I just got away with it, and as you can see there, if I try and pull that out at all, they won't move. Those heavy duty cable ties, you know yourself, if you've ever used them, you can tie on hubcaps on cars or whatever, they're practically indestructible. And the plastic in the open wire feeder seems to be strong enough to hold itself in place. And then the other thing, the reason why I just use these wing nuts is just so I can obviously loosen them, take the cable tie out and remove the cable if I ever need to do that. You know, if the antenna gets damaged or whatever, you know, you want to leave access to certain things. Just another tip as well, I can't remember the diameter of those little bolts, but with this type of plastic, this heavy duty waste pipe plastic, if you drill the hole about 0.5 millimeter smaller than the diameter of the bolt, you'll actually find that the bolt will thread itself in. You know, it just makes for a much more secure connection, and it can be used over and over again then, obviously. So that's that. Obviously now I'm going to get on and make the antenna. I'm going to leave a lot longer of the open wire stripped off and available to solder onto the radiating element of the antenna. just glue this part into position as well, just to stop it from rotating. But I just need to put a spot on when I'm actually just finished up completely, so I'll just leave it that I can take it apart for now. So next part then will be to attach the radiating elements, which will go here onto this section. Okay, so now we're going to solder the antenna legs, the radiating element, to the feed point connector, as I've named this whole assembly. So this is the wire that's coming from the ladder line, and we will have to then solder a loop for the radiating element, and then solder the wire from the doublet to complete the feed point, like so. Okay, now this particular doublet is a half wave on 40 meters, so that's 20 meters, so each leg of the antenna will be 10 meters long. So pretty much all I've done is just simply I just marked off 1 meter length on my bench here, and using that I just marked off 10 meters of wire. So just to be aware that when you're soldering, when you're constructing the thing, to leave excess to create the loop, okay, to solder, because you want it to be 10 meters exactly. And I've marked off the 10 meter point on the wire with some marker here, and just marked it with this red cable tie also, so I could see it, and that gives me the 10 meters in length exactly to this point. And I've marked the opposite end of the cable as well, to when we make the loop for the insulator at the other end, it'll loop in here, and then that gives me the excess to basically we'll just twist these together and solder them, and in twisting them together we'll twist together the should have tightened that a bit better, we'll twist together the wire from the ladder line. Okay, so they'll all go together like that. Yeah, just one other thing that I'm going to do is I have this heat shrink tubing, and just as an extra piece of weatherproofing, when we have the solder join, I'm going to cover the join with the heat shrink tubing, just to tidy it up and weatherproof it that little bit more. Okay, so the next thing we'll do is we'll get on with the soldering. So one thing that can be easily done with this Flexweave wire is that you can just make a little hole in it, and just thread through the tail of the loop, I suppose, whatever you want to call it, like this. Okay, and when we'll solder this, we'll put this wire under some tension just to keep it straight, and also the feed point, the wire from the ladder line, so that's all going to twist in there. I'll just leave this a little bit slack so that when it's pulling in the wind, it's not going to pull this at the same time, so leave a little bit of slack on that. I was just looking at that earlier on, so we'll just twist those together. So that's the feed point connector completed. As you can see, just a heat shrink tubing there just to cover over the joint, so I'll have to do that in a while. The wire from the open wire, the 300 ohm ribbon, and the radiating elements. Okay, so that's that done. So now I have to get on and do the other end of the legs, the radiating element, and solder on the isolators. The isolator soldered the loop there, and that's the shrink wrap just to cover that part. So that's what that looks like. So that's the other end of the antenna leg. So we'll just repeat that then on the other side, and that's the antenna done then. So next step is to mount it outside. So that's a job, as the mast will be on the side of the house. So we'll get onto that bit next. So I've just drilled out the mast, just with an 8mm bit, and yeah, so now I'm gonna put together the arm. It's basically just going to be a big bolt, this guy here, and that'll be secured from the other side obviously, and that's going to hold the pulley for the doublet. So this is the mast finished. So that's the large bolt I was using for the arm, or I suppose technically they're called booms, aren't they, off mast? Not much of a boom though. And this is the pulley obviously that'll hoist up the antenna. I had those two U-shaped bolts lying around in the shed, and I don't know what they were from. I think they were from something that, you know, when you pick up bits from things you get delivered that you don't use. But anyway, I had them lying around, and that's the pulley obviously, and that's just to stop the pulley from flying off in the wind or jumping off. You could probably get two large washers or plastic spacers or something just to do the same effect, but I had those two there. And then there's just a nut at the end, which I'll probably touch off with some solder to stop it from rotating or anything like that. We'll see if the clearance is enough. You know, the mast, the antenna should be under some tension either when it's up. Each leg will be, so it shouldn't rotate that much or come in contact with the pole. But you know, having not done this before, we'll just have to see how it performs in weather. You know, so we'll see if it works out. But anyway, that's what I'm going with for now. So this is the doublet erected, and as you can see, I used 3 of the brackets, and I managed to get the full 20 meters in. So that pole is about 4 meters long, and if you just come down to here, this is the cleat, just for bringing the whole thing up and down for maintenance, or if the weather gets a bit much or whatever. And managed to bring it down to the end of the garden. So this is the isolator there, and some kind of bungee rope holding it in place. So yeah, that's it. So that's a 20 meter doublet, so a half wave dipole and 40 meters, fed with twin line.